According to the World Health Organization, traffic crashes is considered the 8th cause of death all over the world, which results in more than 1.35 million fatalities per year. From a general perspective, traffic crashes can be categorized into two categories: primary crashes and secondary crashes, where secondary crashes occur as a result of the primary crash within the same geospatial proximity. Secondary crashes comprise nearly 20% of total traffic crashes and 18% of fatalities in our roadways. Here in Wyoming, we encounter several pile-up crashes, especially on I-80. Recently, in March 2020, we had 2 pile-up crashes involving more than 140 vehicles, resulting in 3 fatalities and numerous injuries. Interstate 80 or I-80 is characterized by challenging roadway geometry, steep grades, mountainous terrain, as well as adverse weather conditions. On top of that, we do have high truck traffic percentage. This truck traffic ranges between 30% to 55% of the whole traffic. Unfortunately, truck drivers do not slow down in these weather events, which might result in catastrophic incidents. Increasing the situational awareness of our truck drivers while driving on our roadways might help in reducing the frequency or the severity of these crashes, in particular for this study, secondary crashes. The University of Wyoming Driving Simulator Lab was used to evaluate the Federal Highway Administration Connected Vehicle Pilot project here in Wyoming. The whole experiment and training was provided here in our driving simulator lab, which is considered a high-fidelity driving simulator. This driving simulator, which we use in this study, is a semi-trailer. This simulator is mounted on a motion base with 3 degrees of freedom and 140 degrees of field of view. The whole experiment and scenarios was designed using the open architecture software. A comprehensive training and assessment framework was provided to the participants, where we tested and evaluated the different traveler information messages for the connected vehicle pilot for Wyoming. Among the tested traveler information messages, we had the rerouting, accident ahead, and the distress notification, which mainly focuses on the secondary crashes. A total of 23 professional truck drivers were recruited and participated in the CV pilot to evaluate the different TEMs within the CV pilot. For this study, vehicle dynamics and speed profiles were analyzed to investigate the difference in the driver behavior between the CV and the non-CV environment.
The driving simulator scenario consists of 6 miles of 2-lane two-way highways to replicate the actual traffic operation performance of I-80. Each of the participants has to drive the scenario 2 times. In the first time, which we call it non-CV scenario, no information was given to the drivers. However, in CV scenario, the human-machine interface was turned on and real-time traveler information messages were given to drivers. The purpose is to quantify how driving behavior can be changed under the effect of CV notification. This quantification was performed by analyzing and comparing vehicles' trajectories, specifically relating to speed distributions. To this aim, the scenario was divided into 4 sections according to the environmental condition and the type of traveler information messages given to the drivers. The Kolmogorov-Smirnov test revealed that the speed is not normally distributed, so that we compared the speed distribution by following non-parametric Mann-Whitney U-test. It has been shown that there is a statistical reduction in both mean speed and a standard deviation of speed in CV scenario compared to non-CV, leading to more speed harmonization on the corridor. In addition, all of the participants in non-CV scenario got involved in secondary crashes. However, 23 of them in CV scenario followed traveler information messages and exceeded the roadway once they received rerouting notification, which shows highest level of driver's compliance in CV scenario. The last driver, however, continued to drive on the roadway, but he could manage to stop safely without getting involved in secondary crashes.
To conclude this study, the connected vehicle technology helped in enhancing truck drivers' overall performance. In addition, the rerouting application specifically helped the majority of truck drivers to exit the freeway in harsh winter conditions before getting into the crash site. Additional benefit of the Connected Vehicle Pilot Deployment Program in Wyoming is the reduction in secondary crash, which is the main goal of this study. One driver did not exit the freeway, getting the traveler information message on time. However, he did not end up in a crash. Unlike 100% of drivers during the non-connected vehicles, traveler information messages disseminated to them, all of them, they ended up in a secondary crash. Another significant contribution from this study is the fact that speed harmonization was found to be much better in the CV scenario compared to the non-CV scenario, leading to the secondary crash scene. Overall, there is a lack in secondary crashes safety studies, and in particular, there is a huge gap in utilizing emerging technologies such as connected vehicle technology to mitigate secondary crashes. In this study, what we found that secondary crashes could be eliminated altogether utilizing connected vehicle technology via dedicated short-range communication and/or satellite communications. I'd like to acknowledge the US DOT Federal Highway Administration and the Wyoming DOT for sponsoring this work. I'd like also to acknowledge and thank my co-authors and students helped with this study.